For diabetics, life is a constant struggle to maintain balance. Equating your carbohydrate intake, constantly monitoring your blood sugar levels, and injecting insulin. It's a never-ending cycle to stay healthy. But now, major advances in chemical engineering could end that cycle. Two labs are tackling diabetes very differently. At Harvard University, more than 2 decades of research aims at automating diabetic care by developing an artificial pancreas.
You've got the sensor, the way that we measure the critical variable, in this case glucose. You've got the actuator, that's the agent of change. That's the thing that influences your dynamic system. In this case, that's a pump delivering insulin. And then you've got the controller, you've got the brains.
Insulin pumps and sensors are commonplace, but developing an algorithm to allow these technologies to work together has proven difficult. But several trials and another one just beginning are putting the artificial pancreas within reach.
In essence, we use a patient model, a computational model, a mathematical model, to forecast into the future. So we get a sense of how past insulin affects future glucose, how the past trajectory of glucose is going to play out over the next hour or two.
Within 5 years, Doyle predicts a fully functional automated system for diabetes will exist. It won't be a single device, but upgrades to devices biomedical companies already offer. 2 miles away at MIT, scientists are hoping to cure diabetes altogether. They've already proven they can do it in mice. The pancreas is comprised of islet cells which monitor and regulate blood sugar by producing insulin. For type 1 diabetics, the immune system kills these cells. The engineers have figured out a way to hide them from an immune attack using a jello-like substance.
What we developed was basically a new material that can act like an invisibility cloak. So this material coats the cells and allows them to function and live, but protects them from the immune system.
In recent years, islet cell transplants and the ability to produce islets from stem cells have shown a lot of promise. But protecting these cells from immune attack was still a major roadblock.
So far we've shown that in diabetic mice we can take these human islets from stem cells and actually cure the diabetic mice for months. We've also shown in primates that we can put these little balls of new material in the abdominal space of primates and see that they don't form scar tissue, which is an important step towards thinking about using them in people.
Translating the successes in mice and smaller primates to human trials is still years away. Both camps agree that diabetics of the future will not have their lives dictated by their disease.